When you open RStudio, you're presented with 3 panes. Let's talk about what each one of these do one by one. On the far left is what we call the console window. And when you open up RStudio, it lets you know what version of R you're working with, etc., etc. And you're presented with some sort of prompt. And at the prompt is where you could start typing commands. Maybe I want to add 3 plus 4. Maybe I want to take 7 and raise it to the second power. Maybe I want to load in a data set that R knows about called faithful with the data command. And maybe I want to make a plot of that sort of data with the plot command. So we could, in theory, just do analytics completely in the console by typing out one line at a time. Now, that's old school R, and RStudio really is designed to allow us to do some coding and analytics more efficiently. So instead, what we're going to be doing is writing our code in files and then running the code from the files in the console window. Let me show you an example of this by going to File, New File, and RScript. You can always load up one of these and just start typing your code up in the upper left-hand window now, which is going to be the File pane here. So if we wanted to add 3 plus 4, if we wanted to square 7, if we wanted to load in the old faithful data, and if we wanted to plot the faithful data, we could write the commands up there and then figure out how to shoot that down in the console window. So how do we do that? As I was typing this, none of these commands actually ended up getting run. You'll notice if I start typing this out, nothing's happening down in the console. I'm not getting a sort of output. In order to actually get the commands that we're typing in these files on the top left to run, there's a few different ways. We can either highlight the code that we want to be running and then click the Run button. You'll notice that it gets shot down here and the output is presented for us. Or what we could do is do a shortcut and press Command Return or Control Enter if you're on Windows. That'll accomplish the same thing of shooting that line all the way down to the console and having it be run. So if I wanted to square 7, I could do that. If I wanted to find the average value of the eruption times for Old Faithful, I could Command Return, Control Enter, and see what that average time was. Now, kind of a cool shortcut, you actually don't have to highlight the entire line if you're interested in running that line. As long as your cursor is somewhere on that line, what you'll be able to do is run that line in its entirety. So for example, if I wanted to take 3 plus 4 times 2, my cursor is currently on that line, so if I click the Command Run or Control Enter, that'll shoot the entirety of that line all the way down to the console so I can see my result. So by doing your coding actually in an open file, that allows you to essentially have all your code in one place. That allows for easy reuse or modification if you need to tweak something up. And that's really how we're going to be doing coding and analytics in this class. Now, most of the time, however, we're going to be working from what's known as an R worksheet, an Rmd file. This is how you're going to be doing the activities, your homeworks, etc. Now, I can open up kind of a blank Rmd file by going to File, New File, and R Markdown. And if it's the first time that you're doing this, it's going to say, okay, I need some additional packages, some additional functionality to do so, and so we'll click Yes. Just like if you're a gamer, you might need to get some DLC, some additional downloadable content. It's the same thing with R in RStudio. R comes with a set of commands in its base package, but if we want to extend the functionality and do more advanced analytics, something that we want to be doing in class, we have to download these additional packages and then load them up in order for R to be able to do so. So I could give my new file a name. I could call it a test file, let's say right here. And I can press OK, and what will happen is it actually doesn't open up a brand new file that's totally blank. Instead, it gives us a template of one of these R worksheets. So what do we see here? We see a bunch of text, and we also see what's known as an R chunk. We're able to mix and match text and R commands, the R output of those commands as well, which is going to allow for easy completion of homework assignments. So we can type as much as we want, but if we do want to use this space to run some R code, what we're going to do is create an R chunk. Now, an R chunk starts out by 3 back quotes and then a set of curly brackets. And inside those curly brackets, we can give the R chunk a name. It's always going to start out with R. And then if we do want to give it some additional name, we can put a space and then give that R chunk whatever name we want it to. In this case, this R chunk is named cars. Now, the R chunk is going to end with a set of back quotes as well. So anything inside that set of back quotes here is going to be code that we can end up writing and running. So summary cars. Cars is the name of a data set that R knows about. If I just have my cursor on that line and do command return or control enter, it'll go ahead and provide me a summary of what's inside that data frame. We have speed, we have distance, and so we're getting the average speed, the average distances, and some additional summary statistics of those things. If we wanted to define our own data vector right here, maybe X contains these different numbers, we can do this just fine. And same sort of thing. We could highlight the whole thing and we could actually click run selected line, or just have our cursor on that line and do command return or control enter on a Windows machine, and it would be able to run that for us. And so this is going to give us a spot to kind of narrate our analytics, talk about what our code is doing, and then also have the code in there as well. And so you'll see this format for all of the activities, all of the homework assignments, and that's really where we're going to be doing most of the typing. All right, so that top left window is going to be our file that we're writing code, we're writing text describing our analytics. The bottom left-hand window, that's the console window. That's where all the action really happens. That's where the commands go, and R is going to be showing us the output. On the top right pane, what we have is the environment tab. And this is keeping track of all of the variables, all the data frames, the functions, the vectors, etc., that we're telling R about. So here we defined a vector that contained those different numbers, and it's appearing in the environment window. R is letting us know that, hey, I know about this object. We loaded up the Old Faithful data set that's built into R with that data command, and R knows that now, okay, Faithful is a data frame that we can end up working with. If I were to say data cars, I would see that getting shot into the global environment as well. And whenever I'm dealing with the data frame, I can always click on these little blue buttons to actually see a little bit of a glimpse on what's inside. So the environment lets you know all the things that R knows about. If you try to reference something that R doesn't know about, maybe take the average value of the elements of the Y vector, you'll get an error saying, hey, object Y is not found, and that's because it hasn't been defined anywhere in the environment. If I were to do this and say, well, let's let Y be equal to the speed column of the car's data frame, we see that now R knows about a vector named Y, and so mean of Y would be able to be computed. So the environment tab keeps track of all the things that R knows about that aren't already built in. We can clear out that environment with the broom icon if we want. If we do that though, R forgets about everything, and now all of a sudden mean of Y, etc., will not actually be able to be computed. We have to redefine that. All right, so what else can R do? What else does RStudio help us out with? Well, it helps us out by visualizing our data as well. We can go and make plots. And for an example of this, we can look at the relationship between the time until the next eruption of Old Faithful and the eruption time itself. So how did this get created? Well, once again, if I go down, let's say choose a different R chunk right here. I'll choose this one. I'll add some additional lines. If I load in the Old Faithful data set, one of these ones that are built into R, I see it in the global environment. We have 2 columns, the eruption time, the time until the next eruption here. If I were to say plot, and then the name of the data set, it would go ahead and make that scatter plot. I could make a histogram, let's say, of just one of those variables, maybe the eruption times themselves. And we'll be able to see the different plots down here in the bottom right window. So plots can appear down here. You can use this as a file browser as well, letting you know kind of what files live in different folders, also what R's current working directory is. We can see what additional downloadable content that R has, these additional packages. If we do want to load in some of this additional content, well, we could either do the check mark for the things we want to load in, or you'll notice that as soon as I click on any one of these boxes, it says what's really going on in order to add that functionality, running that library command to add in those additional features, those additional commands. This is also where we can go to get help. If we need to know how a particular command works, maybe we could do $plot. How does a plot work? Well, there's a few commands called plot. If we were to go and click on one of these, it lets us know kind of a help menu for how the plot command functions. Usually very cryptically written because this is kind of for the programmers out there, but sometimes sometimes the help files are fairly useful. All right, so what's the most important thing that we need to be able to do in order to succeed in this class? Well, that's making sure that we're able to knit all of our documents. Essentially, take this document that we see right here and make it into a Word document. So how can we do this? Well, you'll notice if we're dealing with an RMD file, there's going to be a button called Knit. And if I click on this and click Knit to Word, it's going to convert this file into a Word document that I could further edit in Word if I really want to, but I won't need to. If I click this, it's going to say, okay, well, let's make sure to actually save this as a file first. And I'm going to go into my classes and then my BAS 320 folder. I'm going to save that here. Let's just do this a test document. Why not? And so what that will do after you've knitted it, it'll open up the Word document and you can go and change any of these things that you need to, but you really shouldn't. You wouldn't need to because the way that you've created the RMD file, it's going to look nice and pretty where we have that mix of text and then also the output from all those lines of code that we've put in there. Not only the lines themselves, but then also the results of doing those computations. So knitting is fairly easy to do, and I'm actually going to go ahead and go to your kind of homework number 0 here and open up the test knitting document. So I've downloaded the relevant files from Canvas itself, and I'm going to do File and Open. And what we're going to be looking for is this test knitting fall 2023.rmd. And also you want to make sure that testimage.jpg is in there as well. If I double click this, what I have is an RMD file that basically is going to create a really fancy looking document that shows you some of the functionality of an RMD file, how you get different fonts, how you get different sizes, how you put in an image file, how you get code to run, etc. You don't need to actually make any sort of changes, but it shows you the basics of embedding images, embedding equations if you really wanted to go there. The main thing that you're going to do is literally just click the knit button to make sure you're able to knit and create a Word document that's based on that RMD file. So once you've done that, you can scan through, making sure those images kind of are embedded in there. If they're not, that just means, hey, you need to make sure that image is in the same place. And the one last thing that you should really do before actually going further in this course is to make sure that your working directory is set up appropriately. Now, your working directory is a folder on your computer that you're going to tell R to look for files. So sometimes we're going to be reading in data files from our computer. Sometimes we'll be putting images into RMD files. And all of these files need to live in the same place. If I go to the Files tab right now, it lets me know kind of what the current working folder is. And right now it's my home folder. You probably don't even know where that is on your laptop. I don't know really where it is either. That's also reflected in the path at the top of the console window. And the home folder is referred to as a twiddle and then a kind of a slash. So what we really want to do is we want to create a folder on our computer, maybe named BAS 320 or whatever class you are taking, and be putting all of the files that you need for that class in that folder so that everything does live in the same place. So what I have here is my BAS 320 folder. Notice I have that test document RMD that we created, the test knitting 2023 RMD, the Word document that got knitted, etc. And what I'd like to do is to create or have this be the current working folder. If I was going to create data files or put data files into R, I want to make sure to have all those data files living in this folder so this works. So what I want to do is I want to change my working directory to be my BAS 320 folder. To do that, I'm going to go to Session, Set Working Directory, and choose Directory. This will bring up a File Explorer. It'll show you all the folders that you could potentially choose. I'm going to navigate to this because I know I put this in my Classes subfolder, and then BAS 320. I'll double click that and then just click Open. And what we'll see is that the file pane has updated to show me the files in my current working directory, and the path at the top of the console is letting me know what folder R is currently looking for files. Now, one shortcut, and this is, we can kind of set this and forget this, is we can permanently change what the working directory is of RStudio by going into the Tools and Global Options. If I go to Tools and Global Options, it's going to allow me to set my default working directory. Right now, it's just twiddle. That's my home folder. What you're going to want to do is you're going to want to click Browse and then navigate to where your BAS 320 folder is, or whatever folder you're using for this class. So I'm going to click Open. I'm going to click OK. And now every time I restart RStudio, that working folder, that working directory is going to be that folder that I've specified. Some other cool things you can do, if you go back to Tools and Global Options, you have an option for kind of changing the way that R looks. You can go to the code, the console, the appearance, the pane layout. You can go into dark mode. You can change it to different colors for the fonts, etc., etc. So have fun kind of playing around with some of these things that you might want to change. The R Markdown one is really one that I like a lot because it allows you to kind of change the way the R Markdown looks. You'll notice that as I was going through some of these examples, what happened is that the plots showed up in the plotting window. The output for commands showed up down in the console. Sometimes that happens, sometimes it doesn't. If you go to the R Markdown and click the Show Output Inline for all R Markdown documents, having this check actually tries to embed the output in the RMD itself. Having it unchecked, which I think is the way to go, actually goes ahead and puts that output in the console and puts that in the plot window. Notice what happens if I click Show Output Inline for all our Markdown documents. If I apply and click OK. If I were to go back to my test document, notice what happens when I do summary cars. It actually tries to embed it in the RMD. So if I have the output in line, if I click, say, plot pressure, it's going to try to put that plot in the RMD file itself, give you a preview, and maybe I don't really want that to happen. Maybe my plots are really, really big, and it kind of goes off the screen. So by going to that tool, Global Options, R Markdown, and unchecking the Show Output Online for all our Markdown documents, that's going to ensure that when I do make a plot, it goes into the correct place. And I can remove whatever is embedded right here and make that go away. The other way of doing that actually is this with the little gear tool. Click on this and you can say, hey, I want the chunk output in line, or I want the output in the console. Inline kind of makes it where the RMD file is, and then in the console makes it so that we get stuff in the console and then also the plotting window. And that's your overview of RStudio.